Hello dear students. Today we will discuss a very beautiful topic from class 12, alternating current. Generally we all know there are two types of current sources. One is DC, another one is AC, direct current and alternating current. Now we should know what is DC. If we plot this current with respect to time, then that will be the graph. So it is very clear that here both the direction and magnitude of current remain constant with respect to time. That means DC current does not depend on time. It is time independent. Now, what is AC? If we plot it with respect to time, then that will be the graph. So from graph, it is clear that here both the direction and magnitude of current alternately varies with time. So we can say that alternating current depends on time. It is time dependent. Also, we have to remember few things about AC current. For AC signal, both the voltage and current have same value of frequency, but they may be in same phase or not. That means they will not always be in same phase. They may be in same phase or there may be some phase difference between them. And generally, for AC signal, the voltage is represented by V equal to V naught sine omega t and current I equal to I naught sine omega t plus phi, where V naught and I naught are respectively the peak values of voltage and current, or sometime we can say that this is the amplitude of voltage and this is the amplitude of current. Omega is the angular frequency, where the formula of omega is 2 pi f. F is linear frequency, which is represented by the unit hertz. And phi is basically the phase difference between current and voltage. Now we will calculate the average value. So the average value in full cycle. What is the meaning of full cycle? As we know, for AC signal, the voltage is represented by V naught sine omega t and current is generally represented by I naught sine omega t plus phi. And if we plot them with respect to time, then that will be the graph. Full cycle means 0 to 2 pi. 0 to 2 pi. And here we plot it with respect to time. So that will be 0 to capital T. Capital T means time period. Time required to produce one complete wave. And that thing is known as half cycle. 0 to T by 2. So the average value of voltage in full cycle is Vf is equal to 0 to T V dt divided by 0 to T dt. So that will be 0 to T V naught sine omega t dt divided by T. If we integrate and put the limit, that value will be T. So after calculation, that V average will be equal to 0. Similarly, we can say that in full cycle, the average value of current will also be equal to 0. Full cycle means if we talk in radian, that is 0 to 2 pi, and if we talk in time, then that will be 0 to capital T. Capital T means time period. Now, if you don't know how to calculate the average value, then no problem. Just go and see the video calculation of average value from my channel. It will be crystal clear for you. So now we will calculate the average value in half cycle. In half cycle, the average value of voltage will be 0 to T by 2 V dt divided by 0 to T by 2 dt. Now 0 to T by 2 V naught sine omega t dt divided by T by 2. After calculation, that value will be 2V0 by pi. Similarly, if we calculate, then average value of current will also be 2I0 by pi. So we have to remember these two results. In full cycle, the average values of current and voltage both are 0, and in half cycle, the average value of voltage is 2 V0 by pi, and for current that is 2 I0 by pi, where I0 and V0 are respectively the peak values of current and voltage. Now we will calculate the RMS value, which is very important for exam purpose. RMS value. What is the full form of RMS? The full form of RMS is root mean square value. Now, at the time of solving numerical, you have to deal it from behind. That means if you want to calculate the RMS value of any quantity, then first you have to take the square of that quantity, then you have to take the mean of that quantity and then square root. So according to this definition, if we calculate IRMS, that means RMS value of current, that means first we have to take the square of current, then we have to take the average, and this is the symbol of average, and then square root. So this is basically the IRMS. Similarly, what we can write for VRMS, that will also be square of V voltage, then you have to take the average, then square root. So this is RMS value of current, this is RMS value of voltage. Now we will calculate the RMS value of voltage. VRMS is equal to square of voltage, then mean, and then root. So we can write VRMS square is equal to average of V square. So from here we can write 0 to t V square dt divided by 0 to t dt. After putting values, VRMS square, that will be, in denominator there will be t, so after putting the limit, that will be t, and in numerator that thing will be v naught square sine square omega t dt. So after calculation, that VRMS square will be v naught square divided by 2. If we calculate it, then that value will be v naught square by 2. And we can write from here VRMS is equal to v naught by root. Similarly, IRMS is equal to I naught by root. So these are the RMS values of current as well as RMS values of voltage. We know for AC signal voltage is given by V naught sine omega t. So now how we can calculate the RMS value of voltage? This is the formula. We know first you have to take the square, then mean, then root. So VRMS square is equal to average of V square. So we can write from here V naught square sine square omega t. So now V naught is the constant because this is the amplitude or peak value of voltage. So V naught square will be come out from the average symbol. Now inside the average, that will be sine square omega t. So what is the value of sine square omega t? We know the average value of sine square or cosine square function in full cycle is always half, and the average value of sine function or cosine function in full cycle is always 0. So in full cycle, the average value of sine square function is half, so that will be half. So now VRMS square is equal to V naught square by 2. So we can write VRMS is equal to V naught by root 2. This is another way to find the RMS value. Actually, for exam purpose, we use this trick several times to find the RMS value very easily. Let's solve this problem. Here current is given by 4 plus 6 sine pi t ampere. You have to find the RMS value of current. You have to find IRMS. So how we will calculate? As we know, IRMS square is equal to average of square of I. Now we can write from that part. If you take the square of current, that will be 16 plus 36 sine square pi t plus 2 into 4 into 6. That means 8 into 6, 48. That means 48 sine pi t. Here we can break it in this form: average of 16 plus average of 36 sine square pi t plus average of 48 sine pi t. Now here it is clear that 16 is a constant, so its average value is always 16, plus 36 is the constant, so it will be come out from the average symbol, and inside the average symbol there will be sine square omega t. Similar rule will be applicable for 48. 48 will come out from the average symbol, and inside the symbol there will be sine pi t. And we just learned that the average value of sine square and cosine square in full cycle is half, and average value of sine and cosine in full cycle is 0. So what will be the value? 16 plus 36 into half plus 48 into 0. So the value will be 16 plus 18 plus 0, that will be 34. So IRMS square is equal to 34. So we can write IRMS is equal to root over 34 ampere. That will be our final answer. See this question. Here current is given by I1 cos omega t plus I2 sin omega t. and you have to find the RMS value of current. According to the definition, we can write IRMS square is equal to average of I square. Then what is the square of I? If you take the square of I, that will be I1 square cos square omega t plus I2 square sin square omega t plus 2I1 I2 cos omega t into sin omega t. We can write I1 square cos square omega t plus I2 square sin square omega t plus I1 I2 sin 2 omega t, because sin 2 omega t is equal to 2 sin omega t cos omega t. Just like we know sin 2 theta is equal to 2 sin theta cos theta. This is the formula that we use here. After calculation, that value will be I square will come out, and that will be average of cos square, that will be half, plus I2 square will be come out, and that will be average of sin square, that will also be half, plus I1 I2 will come out, and that will be average of sin 2 omega t. And as I told, average value of sine or cosine in full cycle is always equal to 0. You have to remember that thing, that will be 0. So the value will be I1 square by 2 plus I2 square by 2. We can write I1 square plus I2 square divided by 2. So that will be IRMS square. Now what will be the result IRMS? So IRMS will be square root of I1 square plus I2 square divided by 2. That will be our final answer. Now we will talk about power dissipated or power used in AC circuit. So as we know, for AC signal, the voltage is given by V0 sin omega t and current is given by I0 sin omega t plus phi, where phi is the phase difference between them. So we have to remember, whenever we talk about power, for AC signal, we always talk about average power, because there is no importance of instantaneous power for AC signal. That is why always we talk about average power. And the formula for average power is basically I0 V0 by 2 into cos phi. So we can also write I0 by root 2 V0 by root 2 into cos phi. So we can write that thing IRMS into VRMS into P dot F, PF. So this is the formula for power in AC circuit. So now the question arises that what is PF, sir? Actually PF means cos phi. Cos phi means PF, that is power factor. You have to remember that thing very carefully, because that question is very important for exam purpose. What is power factor? If you take the cosine of phase difference between current and voltage for AC circuit, then that term will be known as power factor. Just see here phi is the phase difference between current and voltage. So after taking cosine of phi, that term will be cos phi. So that is power factor. If any circuit 45 degrees is the phase difference between current and voltage, then what will be the power factor? So cos 45 degree. Then the value will be 1 by root 2. Now we will talk about pure resistive circuit. So what is pure resistive circuit? It is a circuit that contains only by a resistor. So that is the pure resistive circuit. A resistor is there, and that is the source. Source here, the source we use, this is AC source, that is the symbol of AC source. So let's see, V equal to V0 sin omega t is the applied voltage, and at any instant t, I is the current in the circuit. So here the voltage across resistor is V equal to IR, because at any instant t, I is the current flowing through the resistor. So we can write V0 sin omega t is equal to IR. Now we can write I equal to V0 by R sin omega t. So we can write I equal to I0 sin omega t, where I0 is basically V0 divided by R, and this is the current in the circuit, and that is the applied voltage in the circuit. If you see carefully, here the applied voltage is V0 sin omega t and current in the circuit is I0 sin omega t. So there is no phase difference between current and voltage. So what is the value of phase difference between current and voltage here? So that is 0 degree. That is 0 degree. That means there is no phase difference between current and voltage. So what will be the formula of power? Power will be I naught V naught by 2 into cos 0 degree. So that will be I naught V naught by 2. And what is the value of power factor here? The value of power factor here is 1. Why? Because cos 0 degree is equal to 1. And what is the peak value of current? Peak value of current I naught is equal to V naught by R. So it is clear that to get the peak value of current, we have to divide the peak value of voltage by resistor. Now we will represent it by the help of phasor diagram. So what is phasor diagram? Let's say this is x-axis, this is y-axis, and that is basically a line which represents voltage. So that thing is omega t. So this is V, and that thing is the peak value of voltage V naught. The current will also be in the same line. Why? Because there is no phase difference between current and voltage. This is current, and that is the peak value of current. I naught is always less than V naught. So this thing is called the phasor diagram. Okay. Now we will talk about pure capacitive circuit. What is pure capacitive circuit? It is the circuit which contains only by a capacitor. So that will be the circuit. This is the capacitor having capacitance C, and this is the source. Let the applied source voltage is V naught sin omega t, and I is the current at any instant t. So at any instant t, charge on the plate of the capacitor Q equal to CV. So we can write Q equal to CV naught sin omega t. At that instant t, if we want to calculate the value of current in the circuit, then we have to differentiate it with respect to time. So that will be CV naught sin omega t. Now we can write dq dt is basically rate of flow of charge. This is known as current I. So we can write CV0 omega into cos omega t. Now we can write I equal to V naught divided by 1 by omega c. I think it is clear that we can write it V naught divided by 1 by omega c, and that will be cos omega t. So now we can write I equal to I naught cos omega t. We can also write I equal to I naught sin omega t plus pi by 2, because sin 90 plus theta is basically cos theta. Sin 90 plus theta is basically cos theta, and here I naught is equal to V naught divided by 1 by omega c. Now from Ohm's law, V equal to IR, we know current I equal to V by R, that means voltage by resistance. So here I naught is equal to, that means peak value of current, is equal to V naught, that means peak value of voltage, divided by 1 by omega c. So 1 by omega c is basically here instead of the resistance. So we can say that the dimension of 1 by omega c is basically equal to the dimension of resistance. So what is the nature of the term 1 by omega c? It is basically resistance, opposition. So 1 by omega c term is basically known as chi c. This is known as capacitive reactance. Capacitive reactance. So what is capacitive reactance? When AC current flows through a capacitor, then the amount of opposition offered by the capacitor is known as capacitive reactance. It is represented by the symbol chi c, and its unit is ohm, and its dimension is equal to the dimension of resistance. Now we will analyze all this result for pure capacitive circuit. This is the circuit where at any instant t, I is the current, V equal to V naught sin omega t is the applied voltage. This is the applied voltage, V equal to V naught sin omega t, and current is given by I naught sin omega t plus pi by 2, where I naught is given by V naught divided by 1 by omega c. So we can say chi c equal to 1 by omega c. Now if you see carefully, then it is clear that the phase difference between current and voltage is basically pi by 2. So what will be the power dissipated in this circuit? P average or P, that will be I naught V naught by 2 into cos pi by 2. So here cos pi by 2 is equal to 0. So power dissipated in this circuit is equal to 0. Let's see how funny that is. Though current is present in the circuit, but the power dissipated is equal to 0. Electric current is present in the circuit, but the power dissipated is equal to 0. That is why this type of current which flows in pure capacitive circuit is known as wattless current. Now we'll see few more things. So chi c is equal to 1 by omega c. Omega is the angular frequency, so we can write 2 pi f into c. So chi c and frequency, they are inversely proportional. So what is the nature of graph between them? This, if we plot frequency in x-axis and capacitive reactance along y-axis, then that will be the graph. For DC signal frequency is 0, because for DC signal there is no fluctuation of current or voltage, it is constant, so frequency is 0. So what will be the value of chi c? That is basically infinity. And for AC signal, frequency is basically non-zero finite, so chi c, from this relation, chi c will also be non-zero finite. So what is the meaning of that, sir? See carefully, for DC signal, the capacitive reactance is equal to infinite. That means if DC current want to flow through the capacitor, then how much opposition it will face? It will face infinite amount of opposition. Then will it be able to pass through the capacitor? No, sir, because infinite amount of opposition is there. That is why DC current does not flow through a capacitor. But when AC current will flow, then the current will face some opposition, but this is finite. But this is not infinite. This is finite. Few amount of opposition it will face. Though it will face few amount of opposition, it will be able to flow through the capacitor. But for DC, it will face infinite amount of opposition. That is why it will be impossible for DC current to flow through a capacitor. Now we will see the phasor diagram. Let's say this is x-axis, this is y-axis, and this is the voltage V. That is the peak value of voltage. So current will be in the same line of voltage. No, sir, because current lead over voltage by pi by 2. So that will be the line of current. That is current, and it is the peak value of current I naught, and that angle is basically 90 degree. So current is lead over voltage by pi by 2. Now we'll talk about pure inductive circuit. So what is pure inductive circuit? Such a circuit where only inductor is present and the applied source voltage is V0 sin omega t at any instant t. I is the current in the circuit. From the chapter electromagnetic induction, we know when I AC current flows through an inductor of inductance L, then the back EMF or EMF in the opposite direction that is generated inside the inductor is minus L di dt. So by applying KVL, what is the total value of voltage in this circuit? That is basically V plus minus L di dt is equal to 0. So now we can write V equal to L di dt, V equal to V0 sin omega t is equal to L di dt. So we can write di is equal to V0 by L sin omega t dt. If we integrate, then that value will be I equal to minus V0 by omega L cos omega t. So we can write here I equal to minus V0 by chi L into cos omega t. So that thing is known as I equal to minus I naught cos omega t. So we can write I is equal to I naught sin omega t minus pi by 2. Where I naught is basically V0 by chi L. Now what is chi L, sir? Chi L is basically omega L. This is known as inductive reactance. We will explain that term. But before that, see this thing. Here applied voltage is V0 sin omega t and current at any instant in the circuit is I naught sin omega t minus pi by 2. That means the phase difference between current and voltage is pi by 2. But the current is lagged behind voltage by pi by 2. Why? Because the phase of current is omega t minus pi by 2 and phase of voltage is only omega t. So the phase difference between current and voltage is pi by 2 and current is lagged behind voltage by pi by 2. And chi L is basically omega L. It is the inductive reactance. So what is inductive reactance? Inductive reactance is the amount of opposition offered by an inductor when AC current flows through it. Again, capacitive reactance was the amount of opposition offered by a capacitor when AC current flows through it. And inductive reactance, it is the amount of opposition offered by an inductor when AC current flows through it. Capacitive reactance chi C equal to 1 by omega C, and inductive reactance chi L is equal to omega L, where L is the inductance of the inductor. So what will be the power factor here? The power factor will be cos pi by 2. That means 0. So what will be the power dissipated in the circuit? That is also 0. That means current is present in the circuit, but power dissipated is 0. So just like pure capacitive circuit, here also the current that flows through the circuit is known as wattless current. So in pure inductive circuit, the applied voltage is V0 sin omega t, current is I0 sin omega t minus pi by 2, where I0 is the peak value of current. I0 is given by V0 divided by omega L. We can write V0 divided by chi L. Chi L basically omega L equal to 2 pi FL. Phase difference between current and voltage is pi by 2. Power factor equal to 0. Power or average power dissipated in the circuit is equal to 0. So chi L is directly proportional to frequency. If we plot it, along x-axis frequency, along y-axis chi L, then straight line will be the nature of graph. And for DC signal, frequency equal to 0. We know for DC signal frequency is 0. From this relation, we can say that chi L will also be equal to 0. For AC signal, frequency is non-zero finite. Chi L will also be non-zero finite. So what we can say here? So if DC current flows through an inductor, there will be no opposition. No opposition is there. But if AC current flows through the same inductor, then it will oppose the current by the amount chi L. Clear? Now we will see the phasor diagram. This is the x-axis, this is the y-axis. This is the voltage V, and this is the peak value of voltage. So the current is lagged behind voltage by pi by 2. So that is the line of current. This is current I, and the peak value of current is I0. This angle is omega t, and this entire angle is pi by 2. In summary, what we can say? For pure resistive circuit, current and voltage are in same phase. Power dissipative in the circuit is I0 V0 by 2. Power factor is equal to 1. For pure inductive and pure capacitive circuit, the phase difference between current and voltage is pi by 2. Power factor equal to 0. Power dissipative in the circuit is 0. That is why current present in pure capacitive and pure inductive circuits are known as wattless current. For pure capacitive circuit, current is lead over voltage by pi by 2. But for pure inductive circuit, current is lagged behind voltage by pi by 2. I0 is equal to V0 divided by omega L, where omega L is basically called chi L. Chi L is basically called inductive reactance for pure inductive circuit. For pure capacitive circuit, I0 is equal to V0 divided by 1 by omega C, where 1 by omega C is called chi C. Chi C is called capacitive reactance. It is for pure capacitive circuit. Then V equal to V0 sin omega t is the applied voltage, and at any instant t, I is the current in the circuit. So here VR is basically the voltage across resistor. VR is the voltage across resistor. PC is the voltage across capacitor. So we can say VR is equal to IR and VC is equal to I chi C. Why? Because R is the resistance of that resistor, and for capacitor the reactance or resistance is basically chi C. Now we can write for shear circuit that V is equal to VR plus VC. You have to remember this is basically vector relation. Okay. So now sir, current and voltage are vector. No. Current, voltage, they are scalar. But since for AC circuit, they are not always in same phase. They may be in same phase or there may be some phase difference. Just like pure resistive circuit, they are in same phase. But for pure capacitive and pure inductive, they are not in same phase. Though they are scalar, but their directions are not same every time. That is why to represent AC signals, we use this vector symbol. So here, VR0 is basically known as peak value of voltage across resistor, and its formula is I0 into R. And VC0 is called the peak value of voltage across capacitor. Its formula is I0 chi C. Now, by applying the Pythagoras theorem, we can write here V0 square equal to VR0 square plus VC naught square. So that will be V naught square is equal to I naught square R square plus I naught square chi C square. We can write V naught square equal to I naught square R square plus chi C square. So V naught is equal to I naught into root over R square plus chi C square. So I naught is equal to V naught divided by R square plus chi C square. This is known as Z V naught by Z. So where Z is called root over R square plus chi C square, Z is called the impedance. Impedance of the circuit. Impedance is basically the effective resistance. Let's see the phasor diagram, then things will be very clear. As we know, if in an alternating circuit only capacitor is present, then the current will lead over voltage by pi by 2, and if only resistor is present, then current and voltage will be in same phase. Now what will happen if both capacitor and resistor are present in a circuit simultaneously? Since here both present simultaneously, that is why they will compromise with each other and current will lead by some angle, but it will not be able to lead over voltage by pi by 2. So the phasor diagram looks like that. Let's say this line represent VR, voltage across resistor, and this is I, because current and voltage across resistor, if only resistor is present, voltage across resistor, they are always in same phase. Now what about VC? VC is the voltage across capacitor, and we know for only capacitor the current is lead over voltage by pi by 2. So VC will be lagged behind current by pi by 2. This is VC. Now using parallelogram law, we can write these things in this way, and that is basically, that line is basically V. Now from this parallelogram, applying triangular law, VR plus VC, VR plus VC is equal to V is the applied voltage. Now from this triangle, applying Pythagoras theorem, if we apply Pythagoras theorem, then Pythagoras theorem is valid for mathematics. So here in Pythagoras theorem we talk about magnitude. So what is the peak value or magnitude of applied voltage? This is V naught. What is the peak value of voltage across resistor? VR naught. What is the peak value of voltage across capacitor? This is VC naught. So this is the formula. Here this is the applied voltage V, and this angle is omega t, and current is lead over voltage by some angle phi. Let's say this angle is phi. So from this triangle, tan phi will be equal to that perpendicular divided by that base. So perpendicular is equal to VC and base is basically VR. VC is equal to I chi C, VR equal to IR. So we can write tan phi equal to chi C by R, that means 1 by omega C R. Let's see few more important things. For CR circuit, the applied voltage is V naught sin omega t, and current at any instant in the circuit is I naught sin omega t plus phi. So what is phi, sir? Phi is basically tan inverse 1 by omega C R from this relation. And one more thing, what will be the value of power factor here? Power factor cos phi is equal to R by root over R square plus chi C square. Because if tan phi equal to chi C by R, that means perpendicular by base, then definitely cos phi, that means base by hypotenuse, that will be R by root over R square plus chi C square. So we can say that power factor for CR circuit is basically R by Z. Now we will talk about LR circuit. What is LR circuit? In LR circuit, resistor and inductor are connected in series. Here V equal to V naught sin omega t is the applied voltage, and similarly voltage across resistor, is equal to VR, and voltage across inductor, that is VL. So VR is equal to IR and VL is equal to I chi L, because for inductor, chi L or inductive reactance behaves as the resistor. So if we write the peak value, then the peak value of voltage across resistor will be I naught R, and peak value of voltage across inductor is basically I naught chi L. So applying the same rule as the previous one, we can write here V vector equal to VR vector plus VL vector, and after applying the Pythagoras theorem, we can write V naught square equal to VR naught square plus VL naught square. So it will be V naught square is equal to I naught square will be common. So that will be R square plus IL square. We can write V naught equal to I naught into root over R square plus IL square. So I naught equal to V naught divided by root over R square plus IL square. Then this is known as V naught divided by Z. So Z is basically equal to effective resistance or impedance as the previous one, and the formula is root over R square plus chi L square. Now let's analyze this circuit. If only resistor is present, then current and voltage are in same phase. If only inductor is present, then current is lagged behind voltage by pi by 2. But now here simultaneously they present. So what will happen? Current will not be in the same phase of voltage, or current will not lag behind voltage by pi by 2. Why? Because they simultaneously present now. That is why here current will be lagged behind voltage for some angle phi. Let's draw the phasor diagram first, then we will calculate the other values. That will be easier for all of us. We can say that VR plus VR plus VL is equal to V, applied voltage. And here this is the applied voltage and this is the overall current in the circuit. So current in the circuit is lagged behind voltage by some angle phi. This is phi. Current in the circuit is lagged behind voltage by some angle phi. So from diagram we can say that tan phi is equal to VL, because that is VL. So that line, that the value of that line is also VL divided by VR. So we can say I omega L or I chi L divided by IR. So we can say that tan phi is equal to omega L divided by R. Similarly here, power factor cos phi will be equal to R by root over R square plus omega square L square, or we can say that R by root over R square plus chi L square, or we can say that R by Z. This is called power factor. You have to remember all these relations, and the current at any time t in the circuit is given by I naught sine omega t minus phi. Why? Because the current here is lagged behind voltage by the angle phi, and the value of phi is basically tan inverse chi L divided by R. That's it. That part is very important for board exam as well as entrance exam. See you in the next video.